Deliver this
July
immediately. We need those
1940,
vehicles yesterday.
inside a
Colonel.
small room at the U.S. War Department, a technical request was issued, one that sounded almost like a joke, a vehicle capable of carrying 2 soldiers, weighing under 600 kilograms, with 4-wheel drive, able to withstand any terrain, and with a prototype delivered in 49 days. This was not merely an engineering brief. It was a declaration of war against the limits of physics. At that time,
The Blitzkrieg,
the United States
or
had not
Lightning
yet
War,
entered World
struck
War
with
II,
unprecedented speed.
but the shadow of
Across the
Blitzkrieg
Low
had
Countries,
already
the
spread across
mechanized
Europe.
German
The armor
Cavalry
plating on the
units,
turret has shown remarkable
once
resilience
symbols of
in
classical
trials, General.
warfare,
Indeed. This
suddenly
could turn the
appeared
tide,
obsolete in the
provided we
face
can
of
scale
German
production.
tank speed. The
Today,
world
we
needed a
reveal the
hybrid
culmination of
creature
American
agile
ingenuity.
like a horse,
I present to you the
yet
Bantam
powerful
reconnaissance
like a
prototype.
machine. In this seemingly impossible race, only one small company from Pennsylvania, the American Bantam Car Company, dared to submit a design.
By
With just
redefining the load
15
balance, the
engineers,
adaptability improves exponentially.
they had to build a
Look at the
4-wheeled
stress test
monster
results
in
now.
less than 2
It's
months.
stable.
Are we
The
getting
result
the
was
thermal
more than a
transfer we
vehicle.
need at this junction?
It was a philosophy
data
bringing
indicates
industrial
we are
power
exceeding
into
the
spaces
threshold by
where
5
only
degrees.
biological
The caliper reading
adaptation
confirms
had
the
once
deviation.
survived.
See
The
how the tension distributes here when
1940
it
specification
flexes.
created
Yes, the
technical
simulation
paradoxes,
matches
light
the
yet
physical
durable,
model perfectly.
powerful
Now,
yet
the
efficient,
constraints are holding up
mobile
well.
yet stable. In classical mechanics, these traits often conflict. A light vehicle tends to tip on steep slopes, while a heavy one sinks into mud. Before the Jeep, the military experimented with motorcycles and mechanized horses. Both failed. Motorcycles had a high center of gravity, losing balance on uneven terrain. Horses could not sustain speed while carrying heavy loads. The question was no longer which vehicle is faster,
The board has significant
but which
concerns regarding
structure
production
could
as well.
absorb the chaos of the ground itself. Bantam realized that solving this paradox required a new geometry of motion-compliant dynamics.
This was the
Instead
genius
of
of the
fighting the
interchangeable system.
terrain,
Every part identical,
the
allowing for
vehicle had to
unprecedented speed and scale
cooperate
in
with it.
manufacturing.
We need this
Engineers
vehicle
lowered the
ready for
chassis,
patrol immediately.
shortened the
Secure that
wheelbase,
latch and check the alignment
and
now.
distributed weight evenly across 4 wheels. The result was a balanced oscillation system, where every jolt did not destroy the structure, but transferred energy through the suspension. The Jeep's
Old Reliable
formula,
took another hit for us back there.
therefore,
She's tougher than you
was
are,
not
kid.
speed. It was stability within chaos. The first prototype,
From
the
the early
Bantam
peak to the
reconnaissance
powerful Go
car,
Devil, the soldiers
resembled a
simply called it the
skeletal
Jeep, a
steel
nickname that
organism.
stuck.
Its chassis, welded from high-elasticity carbon steel, could withstand impact forces exceeding 10 G, comparable to the landing shock of a small aircraft. Yet the real magic lay in its intentional bounce-controlled elasticity. The suspension system functioned like biological muscle when one wheel struck an obstacle. The force was not reflected backward but absorbed and dispersed through steel leaf springs. This mechanism transformed the Jeep into a 4-limbed animal rather than a mere 4-wheeled carriage. Its engine produced only 60 horsepower. Yet through an optimized power-to-weight ratio and torque design, the Jeep could climb 6 0-degree slopes and cross streams half a meter deep. From this emerged the idea of the amorphous vehicle, one without a fixed shape in motion, temporarily deforming to adapt before returning to equilibrium. In mechanical language, this represented the convergence of elasticity, resilience, and modularity, where every component was precisely sufficient, nothing excessive. Decades later, robotics would describe this philosophy as minimal kinematics. When Bantam unveiled the prototype, the War Department was impressed, but doubted the small company could produce tens of thousands of units. The contract was transferred to 2 industrial giants, Willys Overland and Ford Motor Company. An industrial tragedy began. The creators of the idea were excluded from their own invention. Yet, from an engineering perspective, this appropriation gave birth to a new manufacturing standard. Ford and Willys standardized 97% of Jeep components, allowing parts to be interchangeable between factories, something unprecedented in mechanical history. This system reflected a new way of thinking. War did not require the perfect vehicle, but a perfect process. Thousands of Jeeps were assembled from millions of parts, shipped across oceans, reassembled on battlefields, and operated flawlessly, as if they shared the same mechanical DNA. In that sense, The Jeep became the first artificial organism capable of infinite replication without mutation. It laid the foundation for how we manufacture airplanes, computers, and even smartphones today. Everything can be reproduced, as long as a shared engineering genome exists on the battlefield. The Jeep was no longer just a vehicle, it was a companion. American soldiers gave it dozens of nicknames: Go Devil, Peep, and eventually, Jeep. The name did not originate from engineering manuals but from popular culture. In the Popeye comics, a small creature named Eugene the Jeep could move through any dimension of space. To soldiers, only this vehicle seemed capable of appearing everywhere like Eugene. On a philosophical level, the Jeep embodied an abstract physical concept: polymorphism, the ability to maintain function despite environmental change. From the Sahara Desert to the jungles of Burma, it adapted without redesign. When the first Jeeps crossed terrain that tanks could not traverse, soldiers described them as creatures stepping out of the fourth dimension. In a world of steel and oil, the Jeep became a metaphor for mechanical life, a system that could endure stress, a dying form, and continue moving forward. The Jeep was not just a car. It was a mechanical answer to a biological question: how to survive in a chaotic environment. From a rushed 49-day blueprint, it gave birth to an entire industry of agile mobility, from off-road vehicles to Mars exploration robots. And when we watch a Jeep climb a steep hill, it is not merely an engine turning wheels. It is science imitating life, a symbol of humanity's ability to transform rigid matter into something adaptive, and to turn war itself into a laboratory of technological evolution.